with you on the middeck.
Okay, say hello, guys.
Smile, Rich. Okay,
we could have middeck down.
We are with you on the middeck.
Okay, say hello, guys.
Smile, Rich.
This is Mission Control. These views are from Endeavour's payload bay cameras as it flies down across the southern Pacific Ocean. On this orbit, it will pass just slightly north of the tip of New Zealand. This is Mission Control. These are our real-time images from the XR radar processor aboard Endeavour. This data take is to calibrate the radar antennas on both the SIR-C and the XR systems. It's being recorded on both radar systems on board and downlinked real time. These are the actual radar images seen by the antennas. On the ground at Oberpfaffenhofen, Germany, there are 24 locations with active radar calibrators in the X, C, and L bands. It's about 7 o'clock in the morning there on Friday, and it's still very, very cold in this area, so the folks who are out supporting this data take are having to bundle up against the really cold weather. We're now getting right over Germany. And while this radar data take is going on, also outside on the ground there's a group of students, and they are, while this data is being gathered by the radar systems, taking measurements of the agricultural areas, the crops, biomass, and soil moisture samples. All of this information will be correlated by the scientists for the most complete picture of the area and of the calibration.
And 295 looks good, Endeavour.
These are the German Alps showing up now on the radar. Now we're approaching the super site at Oberpfaffenhofen, Germany, where the 24 locations with their active radar calibrators are set up. And the Munich airport passing right below. Oberpfaffenhofen is just outside Munich. And the Danube River now in the picture.
Thanks, Craig. The Space Shuttle Endeavour is now in the 7th day of its 10-day Earth observation flight, part of a larger project codenamed Mission to Planet Earth. With its powerful space radar laboratory, it's taken pictures of our planet never seen before. Incredible images from the Alps to the Amazon Valley. The information being gathered will be made available worldwide, helping us to protect our environment. Tom Jones is a mission specialist aboard the Endeavour, and he joins us from 120 miles in space. And here on Earth, we're really excited to have 3 high school students to help with the questions. Good morning, Tom.
Morning. It's a pleasure to be with you all this morning.
It's a pleasure to have you with us. Based on what you have seen so far and some of the initial data you've been able to look at, what do you think it's going to tell us about the health of our environment?
I think this is an important first step. We hope to prove that out here in our payload bay on Endeavour, we have a set of instruments that can help us conduct long-term monitoring of the Earth. And this is its first test flight of a system that can teach us a lot about our planet, how its present health is, and how it's changing into the future. Hope to establish that this kind of Earth monitoring from space is a valuable tool for us to use on into the 21st century as we try to understand and protect the environment.
All right, now we're going to let the students have a chance to ask you some questions. First, Daniel Radomski from Tom's alma mater, Kenwood Senior High School in Essex, Maryland. Fire away.
Do you feel the images that you bring down will finally show the people of the world that what needs to be done concerning ecological problems?
I think so. I think that what we can do with this flight of the Shuttle Endeavour and the Space Radar Laboratory and future flights on both the shuttle and on unmanned satellites will help identify the real problems around the world. We all heard about problems around the world like deforestation and air pollution and water pollution and the destruction of the environment. And we would like to find out the firm numbers that go along with these problems. We would like to know how fast these processes are occurring. And I think with real information on hand, gained from platforms like ours in space, we can really understand where we have to focus our efforts, and that can really help us save a lot of effort and money in the long run, and also make our efforts pay off sooner.
All right, right now we have a question from Sophia Yakrin of New York's Bronx High School of Science.
Hi, how will the images obtained by the space shuttle help scientists distinguish between human-induced environmental changes and natural forms of environmental change?
Well, we can do that in a number of ways. The three kinds of radar wavelengths that we use out on the payload bay can return images not only of just the hard rock and soil of the Earth's geology, but we can also see differences in the vegetation, in the water content of the soil, the extent of snow and ice cover on the ground. And for example, we can use our cameras as well as the radar here to see changes in forests around the world. In the Yucatan of Mexico, we've observed forests that have been killed by Hurricane Gilbert back in 1984, and we can take images of those with the radar and with our photography. We can also compare those kinds of natural scars in the forest with the kind of timber cutting that's going on all the continents of the world, where people are clearing the land for both industry and for agriculture. And so those kinds of patterns can be measured very precisely from the shuttle, and we can understand how fast the process of losing vegetation is going on.
All right, our next question comes from Chuck Berninger from Paramus High School in Paramus, New Jersey.
Okay, good morning. How do you think that this mission... Okay, how do you think this mission and everything that you are experiencing on it will affect your life both mentally and physically when you return?
Well, that's an easy question, I think, for me to answer. This is certainly the most exciting week I've had that I can ever remember. This is my first trip into space, and it's the culmination of a lot of hard work, school along the way. I went to 5 years of graduate school after going to college, plus a long career in aviation and science. So I worked very hard to get here, and all of my crewmates have as well. And so for us, it's very rewarding professionally and personally to both achieve a goal of flying in space and also to see the beauty of our Earth from above. So this is an unforgettable week. I know my family won't forget it because of all the hard training and separations that we've had in the past year. So this is sort of the climax of all of that work. Now it's very rewarding to see that our experiment is going so well and that we're really bringing back the information about our environment that we came to get.
All right, Mission Specialist Tom Jones, thank you so much for joining us this morning. We're getting a kick out of watching your necklace float around your neck there this morning. Your first experience with weightlessness and his first shuttle flight. Thanks again for your time. Best of luck to you, and we'll be looking for you for a safe landing on Tuesday.
Thank you very much. We appreciate that, and thanks for paying such close attention to our flight.
Our pleasure. We've been enjoying the spectacular pictures. Right now we're going to go back to John.
Houston, Endeavour.
Go ahead, Endeavour.
Yeah, Nancy, just a heads up from our view, it looks like the great floods of the Midwest are going to continue. It's got some tremendous thunder and lightning out there.
Roger that, Rich, and they were discussing yesterday in the press conference about trying to use some of the data from your flight to help out with that, and I'm sure the folks in that area would be really looking forward to that.
The short story is we got about 21 mags of Linhof that we've shot and about 5 left, and we've got about 5 mags of CIR left, and we're rationing everything else pretty heavily. and we'll get back to you with a full status when I count it up.
Roger that. Starting to sound like that's our limiting consumable.
You bet. No, we'd shoot camcorder out the window until you decide to bring us down. This is just wonderful. If my fingers don't get calluses for doing all the maneuvers, and if we don't run out of food, we can stay up here 3 months.
We copy that.
Again, the orbiter is still in darkness. It's still before sunrise on the California coast, but the radar can see through that as the California coastline comes into view. On a northeasterly track, Endeavour will cross the coastal ranges, which are mountains that are made from various fault lines. Should also cross over the San Andreas Fault just before the San Joaquin Valley, which is coming into view, a large agricultural area. The orbiter is now crossing the Sierra Nevada to the Mammoth Mountain area, which is a backup super site, which is on the eastern part of the Sierras. As mentioned, this is a hydrology site. The interest here is for the snow cover and the amount of snow cover in that area because of the production of water that the Sierras produce for the Southern California area. The scientists are trying to understand and find a better method of using radar equipment to measure how much water is contained in the snowpack on these mountain ranges. The interest here is primarily because Southern California gets hit with drought quite frequently, and so it's important to understand the amount of water that's available in the snow-covered mountain areas. The orbiter is now moving toward the Nevada area and the Nevada Basin and Range, which is a series of ranges, mountains, and valleys which are formed as the land literally pulls apart in that area.
Go ahead.
Ben, this is Tom. We're looking at the sunrise here, and the aft portion of the antenna is completely in shadow, about the last 3 panels, all the way across from X to C-band. So if that temperature data is of any interest, you can look at it now.
Okay, I copy that, and I'll pass it on to the engineers.
Copy.
This is Mission Control Houston. These are views as Endeavour makes a southeasterly swing across the eastern portion of the United States. Endeavour is on a southeasterly track now, out over the Atlantic Ocean just after crossing over the coastline of the east coast of the United States. The orbiter's in a nose-forward position with the payload bay of the orbiter pointed toward Earth.
Right. Hello, I'm Kevin Chilton from Los Angeles, California, and I'd like to welcome you aboard the Space Shuttle Endeavour. You know, as you can well imagine, it takes a lot of folks to get a mission like this ready to fly, starting with the people out in Palmdale, California, who built the Space Shuttle Endeavour, folks at the Kennedy Space Center in Florida, who did such a wonderful job of getting us off the pad, our good friends at the Johnson Space Center down in Houston, Texas, who at this very moment are monitoring every system on board Endeavour to make sure we have a safe and successful flight. Then there's the folks at the Langley Research Center and the Jet Propulsion Laboratory who built our wonderful payload out in the cargo bay that's performing so well on this mission. You know, there's another group of folks that I kind of think are the unsung heroes of this flight that I'd like to talk a little bit about today. Turns out there's a team of 19 scientists, college students, and plain old volunteers scattered all over the world performing a very important role for this mission. From the high plains of Tibet to the Amazon jungles in Central and South America, to the frozen forests of the Upper Peninsula of Michigan, down to the dry deserts of Death Valley, California. These people are helping us solve a very tough problem we have on the first flight of a radar laboratory mission. Turns out these 19 teams know their specific areas like they know the back of their hands. They've cataloged the location of every tree. They know the rivers. They know the landscape. They know the moisture content of the soil. More specifically, they know what type of season it is there. Is it dry? Has it been cloudy? What exactly was going on the ground when we flew overhead in the shuttle with the radar laboratory. Get back, we'll strip out the photographs from all the data that we have on board. Those scientists will come together and tell us exactly what it is that we've taken pictures of. In the future, then, we can fly radar satellites and cover the entire planet and learn about it without having people on the ground on various locations or up in space riding along taking pictures out the window. And that's the beauty of the job that these teams are doing for us right now. So we, the crew of Endeavour, would like to give a special salute to those 19 teams scattered all over the world. Thanks for putting up with the mosquitoes and the cold weather and the winds. We appreciate it, and you play an important role for the scientific outcome of this flight. We look forward to seeing you in a few days and to bringing you back some good data. And now, if you'd like, why don't we take a look out in the payload bay? I think the sun is just coming up, and we can enjoy another nice pass of the planet Earth. Thank you.
We had a viewer in the Netherlands who asked a question by fax earlier today about why the radar couldn't do its job without astronauts present. Why is it important that you and your 5 colleagues are in orbit along with the radar?
A very good question. And let me jump just a bit to the future first and say that in the future, we hope it actually does that and it flies on its own, because this is a great system, and I think it deserves to be on its own free-flying platform in Earth orbit. Initially, we're flying it on the shuttle for a couple of reasons. It's a very complex radar system, the most complex one we've flown to date. It has uniquenesses to it at the multi-frequency, multi-polarization, and things we haven't tried before. We're flying with recorders that are state-of-the-art recorders. They've flown once on the shuttle with a single tape kind of mission, and we're flying 3 of them on board now and running 150 tapes through them at very high rates. So we weren't sure that would work right. The radar, we'd like to be able to bring it back between flights and modify it and do maintenance on it if we have to. And you can't do that once you launch it into an unmanned platform. You no longer can get hands on it, so to speak. And the other thing is we're still trying to figure out exactly how to analyze all the data that the radar gives us. So one of the big objectives on this mission is to use orbit-based observations, which we've been doing extensively, along with the people on the ground doing concurrently ground-based measurements, so we can start to put all this together into a better computer, algorithm kind of program that we can correlate the data the radar gets back to what kind of image it needs to produce. And there's still some gaps in that knowledge of how to do that. So right now we're using people to help fill in those gaps. We're using the shuttle as a platform to return it to Earth in case we have to make any modifications or changes, and all this should lead to, we hope in the future, a permanently based in Earth orbit unmanned platform.
A viewer in Derby, England, wants to know if life aboard Endeavour is as cramped as it looks like it is on television. How crowded?
Well, I'll try to describe it, and I have to say it is a little cramped. You know, we have 6 people on board, and we're sleeping in shifts. So right now, 3 of our folks are asleep downstairs in sleep stations. And right now, I'm on one end of the shuttle, one side of it, and this camera's on the other. So you're seeing the width of our flight deck. And the other dimension of it is just about equal to what you're seeing across here. And we have a slightly larger area down below where we have our sleep stations and galleys and for fixing the food and lockers for stowage. But it's pretty cramped. It's kind of about like having 2 medium-sized bathrooms on top of each other in terms of size.
And have you been surprised or alarmed by anything that you've found?
The major significance of the mission, I think, is the place in the big picture of this flight and the mission to planet Earth. It's one of NASA's major projects right now. It came into being officially, I guess, about 3 years ago now, in 1991. And this is just one of a series of projects that is a part of NASA's effort to learn more about our home planet in terms of the atmosphere and the oceans and the land. And I think from a shuttle-based point of view, we've had things that have studied the atmosphere extensively, and we have some of that on this mission with a measurement of air pollution by satellite, our MATS experiment. But we're also concentrating more on the land, which is unique. So that's something I feel good about this mission. I think it's unique in that it is a very intensive Earth science mission. And some of the other things are it's very correlative between people working up here and people working on the ground. So we pulled off a pretty big team effort. And I honestly can't say I've seen anything out the window that's been alarming. In fact, you know, from our vantage point here in space, it's all quite beautiful.
All right, Dr. Linda Godwin, thank you very much for joining us of Endeavour. It's been a pleasure to spend time seeing you when you get back. The shuttle is landing at 15. Oh, same with me. The shuttle will be landing at 15:53 GMT on Tuesday at the Kennedy Space Center in Florida, and we'll see Dr. Godwin once she weighs something again. Sonia, that's our report.
Thank you.
Houston. This is Mission Control Houston. We're now seeing some live downlink images from the X-band synthetic aperture radar in Endeavour's payload bay as it passes 115 nautical miles over the equatorial Pacific on one of its oceanography investigations. The Circe and XR instruments both are observing surface and internal waves, wind motion at the sea surface, and ocean currents. Scientists hope this data will help them understand better how the Earth's climate can be moderated by the ocean, particularly heat transporting currents like those of the U.S. Gulf Stream.